So welcome once again, everyone. This evening we have a special treat with representatives of two robotics teams offering us some of their insights and experiences with respect to the XRP robot. And what we will have is we have Moksh from team 9621. That's Team Payload out in the Durham region. And he will share for a few minutes just an account of some of their team projects connected with the XRP robot. And then we will have Stephen Fong from the new team. I believe it's 10218. Is that right?
That's correct.
Yes, 10218, who will share with us some of their experiences with the XRP robots. And hopefully we'll have some time for some questions and answers. And we will also record this and put it up online for anyone who couldn't make it this evening. So most happy and appreciative that you've joined us this evening, Moksh and then Stephen. And we'll start with about a 5-minute account from Moksh, and then we will turn it over to the new team 10218 to take it away. So thank you so much again. We will hear from Moksh to begin.
Hello everyone, my name is Moksh and I'm in grade 10. I've been part of First Robotics for about a year now and I've learned a lot about coding in Java using these XRP robots. One of the main projects that I've built was making it like a first-person view robot using my steering wheel, and I've set up virtual gearboxes and taken cameras from other devices, and I had it working perfectly with like the RPM lights, the shifters, and virtual reality glasses. So if it's okay, I can share my screen and show a video of how it works.
Certainly.
So yeah, here's a video of how it works. I can just like press the accelerator, it turns. If I just turn the steering wheel, and all the controls work as you'd expect them to. It's kind of a lot like driving a car, in which you would have your shifting, going into reverse, neutral, and since that video I have changed a little bit about the code. It now doesn't let you turn without accelerating, so you have to be going forwards to turn. And I can share my code window so you guys can see what I'm talking about. So here's my code editor. WPIlib has a VS Code, and if I go into my robot container, which is where I actually get the shifting part of it, I'm basically multiplying my controller input to go forward by what gear I'm in, and into the subsystems, I'm able to add one to the gear and then set speeds for each gear. So gear 1 would be 0.6% of full power, gear 2 would be 0.8% or 0.8 of full power, and gear 3 would be 1. And it multiplies it by what the axis gives, and then it moves the robot at that speed. So if I were to simulate the robot code to get the window where it shows how much the controller, like what input the controller is giving, then you'd be able to see how it would multiply what gear I'm in based on the Y value for the Xbox joystick and then how fast it'll go in accordance. So I have my joystick here, and if I set it in teleoperated, axis 1 is what corresponds with where the robot goes, and if I go to my terminal here, I can change the gears, and based on that, the maximum speed for the robot will change. This basically removes moving back, or like moving the joystick to the bottom, and it sets 0 as the -1 or +1 for the joystick, and divides all other values for the joystick by 2 to fill in the gaps for every other value that's being replaced by adding 0.85, and that's adjusting for the stick drift that I have on my Xbox controller. And I just use a normal Wi-Fi FPV camera that I've plugged into the external ports on the XRP robot. Yeah, that's everything that I've done so far for the XRP robot.
Thank you kindly, Mooch. That's a really interesting idea. And I would have loved to have a set of gears on our FRC robot because going at 100% all the time is not always the best approach. So, and really well presented and really inspiring. I hope we can, yeah, take some lead from your example there. And
And
well, that
sorry,
was great.
hello, can you guys hear me?
Yes. How are you doing,
Uh,
Ram?
so fine then. Can we ask questions?
Sure.
So uh so I'd like to use it to try out Swerve. How do you say your name again? Muksh.
Yeah,
Mooch.
just
Muksh.
Moksh.
Have you what would you need to put on it if you want to try and Swerve? You need to have you have to 3D print special wheels or something. Um,
So, sorry, you were saying?
have you thought of it, or does anybody know any research about if we want to put something on it to play with it as Swerve?
So, for my understanding on Swerve, and I haven't coded Swerve, our robot uses tank drive, and we use the arcade drive to control it. But
Mm-hmm.
you would be able to set speed limiters for Swerve using the same way because you're just multiplying your values for your joysticks by whatever gear you're in. In theory, the idea would work, but I'd need to like know how like to code Swerve to give you a proper answer for that.
Okay.
Yeah.
Right. Right. I get. Yeah. Because sorry. So just silly question off the top of my head. Because
Uh,
that's right. So it has tank drive. It comes with what it comes with. I haven't opened one yet, to be quite honest with you. So you said something was it comes with tanks, right? The wheels are for tank drive. You said.
Yeah, so tank drive is basically one motor on each side. Yeah, just
Mm-hmm.
like that picture. Now
Mm-hmm.
you have two ways to code it. Either each joystick represents one side of the motor, or you could have one joystick representing forward and backward, the other one for turning.
Mm-hmm.
Swerve would be similar to a drone where you have one joystick for forward and backward, left and right, and then the other one would either control like the orientation of the robot. Really similar to a drone, you can go forward, backward, left, right, and then turn on an axis.
Ah, perfect. No, that was helpful, Mokshi. That actually did help. That was good.
um,
Some good information there.
I might have a few suggestions for you, Ram, later. You could give me a call later about trying out Swerve.
Okay.
Yeah.
Okay. Thanks.
So that's amazing. Well, thank you again, Mooch. And yeah, really great setup with the XRP.
Thank you.
So we may turn it over to our rookie team. Not so rookie team. They've done a shadow season in the background, haven't they? Yes, 10218. And welcome to Stephen and his assistant, or yeah, XRP expert. And her name is
Ella.
Ella. Very nice to see you, Ella.
Excellent. Well, thank you, William and Moshe. That's absolutely brilliant. Using the WPI robotics library to be able to code the XRP robot, that's absolutely brilliant. Definitely, when we go through this presentation, please feel free to add any of your experience, as well as the other teams too, as well, because we definitely want to make this lesson as interactive as possible. So we represent a small but curious rookie team named No Signal. in a small town named Rockwood, which is about 20 minutes north of Milton and 20 minutes west of Guelph. And a special thank you to William for providing us this wonderful opportunity to give back to you, the FRC community. So as always, we like this session to be interactive. So again, if you can, please turn on your cameras. It helps me to understand if you're nodding your head or if you have a raise your hand for certain questions. Please mute your microphone when you're not speaking, but definitely ask your questions and share your experiences throughout the session. What I'll do is this presentation has also been shared with William, so he'll be circulating this out to all of you after the session. Perfect. So let me share my screen and here. Just let me know when you can see my screen. So I'll go share. Perfect. Okay. That may
There
not.
it is.
Okay, perfect. You can see it?
Yeah.
Excellent, excellent. Okay, so let's move on to the second slide here. So we're just sharing sort of the different screens. So the following is our agenda. We're going to start off with quick introductions, followed by how to build and install the firmware on your XRP robot. Then we're going to discuss how to code the XRP robot using two different tools. One is the XRP code editor, which has two tools, which is Blockly as well as MicroPython. And using the, as Mosk has showed you, it's the WPI robotics library, Visual Studio Code, which is the robot simulator. We'll show a quick video in regards to a final project that our students basically had completed to graduate our program, where the XRP robot will help St. Nick to deliver packages. We're going to share a few of our key lessons learned. And always, we're interested in your questions and we encourage you to share your experiences. And then finally, we will end with a call of action. Awesome. So let's begin to the next slide. So basically, quick introductions. My name is Stephen Fong. I have over 10 years of giving back to students, ranging from junior achievement, starting a business, the Cyber Patriot in terms of hunting for vulnerabilities, and now the first robotics competition. Over 23 years helping the business to move faster, providing a second to none customer experience, and winning in the marketplace. So you may be familiar with some of the companies that are located to the right of the screen. So for Bella, I'm going to ask her a few questions. So what grade are you in, Bella?
I am in grade 6.
Awesome. What is your favorite food?
Sushi.
And in the future, will robots do your chores?
Yes.
Excellent, excellent. And so as part of our program, we encourage our students to build robots so that they can improve the quality of life. And so they're always keeping that in mind when they're designing and building robots. Awesome. So moving on to the next slide here. So this is the, so again, show of hands, how many have you built and operated an XRP robot? Okay, so we have one. I know most you've done yours with the steering wheel, which is absolutely brilliant. Definitely the Indy car racing type format. John, has your team used the XRP?
We've acquired one. We've had it built, but our team is only meeting for the first time tomorrow night. So I get to meet my programmers tomorrow night. So it's on our agenda to talk about it and hand it out to somebody. But so we built it, but we haven't used it yet.
Excellent, perfect. And the gentleman who's on the Google Pixel, have you used the XRP robot before?
No, I got a couple that I have to open still. I got, I think I got 3 of them, but I haven't opened them yet.
Awesome. So it's almost like Christmas. You have the boxes not opened yet and ready to open the gift. That's perfect.
Yeah, I was waiting to listen. I was waiting for your presentation so that I can open it.
Okay, excellent. Thank you. So there are many resources available on the internet. It takes approximately about 15 to 30 minutes to assemble the XRP robot. There's a great video from Rob and Drew, which is an engineer, on how to build the XRP robot and how to connect the robot to the XRP code editor. So I do recommend for you to review that link. We used it for our students as they were building it. Another great resource is Getting Started, XRP Getting Started. And so I'm just going to go over to the other slide deck that we have here. And so there's a website that basically provides you with key aspects of the XRP, resources for building, resources for coding, resources for learning, and resources for connecting. I definitely recommend for you to go to this for this resource. It is actually quite clever. Also, too, we have a link for the firmware. So the latest firmware you can find there. If you ever need to factory reset your robot, what I've done is I've provided instructions here, step-by-step instructions on how to do that, with also pictures as well. One of the reasons why we learned how to factory reset is we had 2 XRP robots with 2 teams. But when we were switching between coding the robot with the XRP code editor, as well as moving to the WPI robotics library, they have 2 separate firmwares. And what you need to do is you need to update the robot with one firmware for one option and the other firmware for the other option, if that makes sense. Okay. And also, too, what we've noticed is that we noticed that when you go to SparkFun, if you want to get a significant discount on the XRP robotics platform kit, please send a message to support, and they can offer discounts to you too as well. Awesome. Things that we noticed with the XRP is that the USB-A to micro USB cable is not included, and the batteries, the 4AA batteries, is not included as well. Awesome. Any questions before I move on? Okay. Moving on to the next area here is that in terms of coding, so in this session, we'll be showing both the XRP code editor, which is on the left-hand side, and we're also going to be showing the WPI robotics library, which Mosh has also showed too as well, which is on the right-hand side. This is the robot simulator. The XRP code editor provides 2 tools. One is a Blockly, which is a visual block editor, and then you have MicroPython, which is a text code editor. And then this one here is the WPI robotics library. Again, you'll be using this with operating your larger size, industrial size robots during the competition. Okay. Moving on to the next slide here. So our team leveraged 2 key resources. One was, and I'll basically provide that up on the screen here. This one here, just make sure we have that. So this is the, okay, so let me click this one again. This one, we actually went through each part of each of the sections of this website. One is actually teaching about the motors. The other one is the ultrasonic distance sensors. This one here where you could actually use a pen and it would follow a line. And then we had one, this is the one for following the line. And then we had one for servos for manipulation, where you want to, say, for example, pick up a small basket. And then the XRP robot also has a component for a web server. And this is where you can actually teleoperate the XRP robot by clicking buttons on a website. Okay. The other resource that we leveraged was Code Academy's Python 3. We basically leveraged the first 5 modules, where that you had control flow, which is the if, elif, or else statements. We had lists and loops, which is for and while, and how to define functions. And with these 2 resources, we were able to teach our students the different functions to use the XRP robot, and as well as complete a final assignment. So in this session, what we'll do is we'll actually go through each of the 6 functions. Driving straight, turn in place, an arc turn where you're actually turning such as like in a small wheel. We have moving the servo arm. We're going to utilize the ultrasonic sensors for acquiring distance, as well as using the IMU for determining which direction the robot is facing. Okay. Any questions Any questions from you in regards to up to this point? What I'm going to do is just going to the next one here. So what we're going to go through is we provided both the Blockly as well as the MicroPython code for each of these areas here. We found that these are the 6 functions we typically use when we were training our students on the XRP code editor. What we are going to do is we are going to be actually showing you this live as we're connecting the robot. So what we do is we go to the XRP code editor, which by going to this website here, which is xrpcode.wpi.edu. When you connect the robot to the robot, your file system will be on this side. So they actually have some really good XRP examples where they have already Python scripts ready to run. The one for installation verification is a great way to test all the features and functionalities of your XRP robot after you assemble it. So if you run this this one script, it will actually check all of the subsystems within your robot. And then so what we're going to do is we're going to go through each one of these examples. So we're going to start off with driving straight, which basically means that both tires move in the same direction. A positive number is the XRP robot will move forward. A negative number, the robot will move backwards. And then when you click onto Blockly, it has a group of different folders and different blocks of different commands. And all you simply do is basically drag that onto the screen. And then what it does is it runs the commands in sequence from top to bottom. So what I'm going to do is I'm going to get Bella to build the first set of commands here. So she's going to the drivetrain folder, then she's going to the logic folder and using the sleep command, then also going back to the drivetrain to get the straight command, and then adding another sleep. And then as she's clicking the boxes, she can then change the values in the arguments. So she's going to change the forward motion of moving 10 centimeters forward. She's going to go back 10 centimeters. And then for sleep, she's going to wait for 1 full second between each of the commands. Okay, perfect. And then when she completes putting the block, she's going to run it. The first thing it's going to ask her to do is to save it. She's going to click onto the default folder location. And then if you move the window a little bit higher, because this is the first function, we're just going to call it A. So whenever you build a block program, it has an extension .blocks, and which she's going to press OK. And then the moment that she presses run, it's going to save the file. And then the robot's going to move forward. And then it's going to wait a second. And then it's going to move back and then wait a second. Any questions in regards to this? What I'm going to do is I'm going to also show this from a MicroPython perspective. Yes,
sorry.
sorry.
I do have a question.
Yes.
Is this I miss which website you've got. Is this a website out there, or is this your own website you were telling us this stuff is posted at?
No, great question. So so the website is xrpcode.wpi.edu.
Oh, thank you.
Okay, excellent. Great question. And so it's great because the team who designed the XRP robots, they provide you with these code editors for free. And it's a great way for your team to learn both a visual programming editor as well as a text as well. Okay, so what I'm going to do is I'm going to show you how to build this code, which is this one here. We're going to be using MicroPython for this one. And so when you click MicroPython, you will have, this will be your default code that is created. What I'm going to do is we recommend to put all your imports of your modules and or libraries at the top of the file. And I'm going to paste that right over here. Okay, so we are going to be using the XRP library, and we're going to import all functions. And then we're also going to import a module or a library called time, so we can put the waiting time of a second. And then I encourage our students just to copy and paste the commands as we do in class into at the bottom here. Okay, and so interesting enough, you see that anything in blue is basically the function, and your arguments are all in orange, and then all your modules or libraries basically are in white. Okay, so what I'm going to do is I'm going to run this command, and I'm going to press the default folder. I'm just going to raise this a little bit higher, and then I'm going to put label it as A, and any Python script will end with an extension of py. I'm going to press save. I press OK, which it saves it, and then it basically runs the script on your robots. So it basically moved forwards, and then it moved backwards. Awesome. And then I'll just basically, and then stops afterwards. Okay. Any questions before we move on to the next function? Okay. So what we're going to do is the next function here is the one for turning in place. This is where the motors will turn in opposite directions. And so, so when the number is a positive number for the argument in terms of the degrees, so when you look at this graph here, 0 is basically facing wherever the robot's facing. When you have a positive number, it'll basically turn to the left. If it's a negative number, it'll turn to the right. So this script here, basically what the first line will do is it will turn 90 degrees to the left, and it'll wait a second for sleep, and then it'll turn 90 degrees to the right, and then it'll wait for another second. Okay, so Bella, would you like to build this one?
Yeah.
Awesome. I like that little clicking sound as though the blocks are clicking, joining together. Awesome. Okay, and then we just need to change this sleep, yeah, that to -90, brilliant. And the sleep to values of 1. Okay, and she's going to run it, and then it's going to ask where to save the file. So it's at the default folder level. Because we are on the second function, we'll call it B, as in Bob. We press OK. Okay, and so once it saves, the robot will turn to the left, and then it'll basically turn back facing forwards. Okay. And what I'm going to do is I'm going to, when you press X here, it'll show the 2 options. I'm going to go to the MicroPython. I am going to copy the import statements into MicroPython. And I always put the imports at the top. And then what I'm going to do is I'm going to put the rest remaining of the Python code into the bottom. Okay. Excellent. And then I'm going to run this. It's going to ask where to place the code. I'm going to put it in the root folder, and I'm just going to put B as in Bob. Press OK. Okay, and the robot is going to turn to the left. Okay. It will pause for a second and then turn back to the right for 90 degrees. Any questions in regards to the first two functions? Okay. So let's moving on to the next one here. This is where it's an arc turn. And if you want the XRP robot to turn in arcs, so it's going to make a very, very large circle. If it's a positive value, it'll turn to the left. If it's a negative value, it'll basically turn to the right. So when you want to turn to the left value will be smaller than the right side. And if you want to turn to the right side will be smaller than the left side. Okay. So this is where that when we want the robot to turn to a circle to the left value is smaller than the right. We use a sleep command to tell it how long it's actually turning the arc. So it's going to turn to arc a full 2 seconds. And then basically it'll say to stop the motors and it'll stop the robot. Okay. So Bella, if you like to build this in Blockly. Okay, perfect. So what I'll do is I will close this, and in Blockly, I'll just bring this a little bit further down so everybody can see it. Awesome. So she's going to go to the drivetrain folder. She's going to select the set effort block. She's then going to the logic folder and she'll select the sleep block. And then she'll go back to the drivetrain and choose the stop motors. Okay, and she's going to change the values so that depending on if you want the robot to turn to the arc to the left or arc to the right, because the left motor is moving slower, it's going to turn to the left, and she's going to have a sleep of number 2. Perfect. And so what she's going to do is she's going to run that. And I'm just going to lift this up because we only have a small table, so the robot may drive off our table, so I'll just hold the robot for the time being. And she's going to save it. And then the robot wheels will start turning. Okay. And it runs for 2 seconds. Perfect. And so what I'm going to do is I'll close this one here. And then I'm going to do this in MicroPython. So we're going to have the import of the libraries at the top. Okay, and then we're going to use these commands here, Python commands, and then we're going to put that down at the bottom. And a lot of these commands are available in the resources that we showed before, that website, but also too, if you look at the XRP examples, they provide a lot of useful code as well. Okay, so I'm going to run this. I'm going to choose the default folder. I'm going to type letter C, which is the third function. I'm going to save it. I'm going to lift the robot up so that it doesn't drive off our table. Okay. And it's going to arc turn for 2 full seconds and then stop the motors. Okay. The next one we're going to do is we're going to move the servo arm. And so if the robot is, so imagine the robot facing to the left of this chart here, the circle chart here. If it's facing to the left, 0 degrees is when the servo arm is facing straight to the right. 90 degrees is when the servo arm is facing upwards, and 135 degrees is facing slightly forwards. And she's going to be using the servo block in the servos folder. So what I'm going to do is I'm going to move to the Blockly. And Bella, if you'd like to build this. So in the server folder, she's going to choose the servo block, then move to the logic folder and choose the sleep block. She'll go back to the servos, okay, and then back to the logic for the sleep, and then back to the servos again, and drag the last block for servo, and then the logic she'll be moving the next sleep. So the servo identifier is number 1. Okay. Oh, perfect. Awesome. So I guess the first degrees, we're going to be setting it to 0. So it's going to be straight to the right. Okay. And then it's going 90 degrees is going to face straight upwards. And then 135 degrees, it'll basically slightly forwards. And then it will return back to 0, which is back to here again. Okay. And so what we'll do is as she's changing the sleep wait time of 1 second. And then she's going to run this and she's going to save the file onto the root folder. This is going to be the fourth function, so it'll be letter D as in David. Okay, and once she presses OK, it's going to save it to the file, and I'll basically show the robot. So, okay, so it went from 0 to 90 degrees to 135 degrees, and then back to 0 again. Awesome. And so what I'm going to do is I'm going to do this also in MicroPython. Again, we'll put the importing of our modules or libraries at the top. Okay, and then we're going to copy the Python script down here. Okay, I'm just going to put it down here. And I do recommend using the hashtags for comments. It definitely helps when the different students are reading and coding their activities. It's easier to understand what the Python coding is actually doing. So I'm going to run this, save it in the root again, move to D as in David for the name of the file. And then it basically what happens is it starts at 0. Okay, goes up, forwards, and then back to 0 again. So, any questions in regards to these two functions? Moving along to the next one here, this is the fifth function we have, which is acquiring distance. This one will use a little more blocks and a number of different folders to acquire those blocks. Basically, what we're going to be doing is that we're going to be using the ultrasonic range sensors. And those are the range sensors that are in the front here, where it uses something similar to an echolocation. Where it's measuring the distance of an object in front of the XRP robots, and it's in centimeters. So it'll emit a signal out, it'll reach the object and then return back, and the distance between where it sends it out and hits the object and basically returns back, it then calculates the distance in centimeters. Okay, so what I'll do is I'll go to Blockly once again, and I'll have Bella to create that. Okay, so she's going to so we're going to the loops folder. So we're going to select the repeats. So the one below, no, not, yeah. And if you choose the wrong one, we can just delete. We can press delete. Okay. So we can go back to loops. We can drag the repeat block. Perfect. Excellent. Okay, and then we're going to go to the logic. Perfect. And we're going to choose the block of true, and we're going to connect it up to the top there. And then we're going to print out the distance. So we're going to go to text, and we're going to choose the print block. And then we're going to go to the sensor folder. And then we're going to choose I believe it's distance, and we'll choose sonar distance. Perfect. And then we go to the logic folder, and then we're going to choose the sleep block. Perfect. Excellent. And so one thing that I want to let you know is that if you choose a very low number for sleep value, the range sensor will have a value of 0. It doesn't have enough time to send out the sonar, hit the object, and come back. So we do recommend 0.5 of a second to be able to get that to function properly. Okay, perfect. So let's run that. Okay, and we can choose the root folder. We can now, this is the fifth function, so we can set it as E as in Edward. Perfect. And so what we're going to do is when we run this, I'll have, we're going to see down at the below where it's, oh, no, it's sitting at 0. Okay, so let me just stop this. So this is sometimes where that's, when you're doing a live video, it sometimes doesn't work as planned. So let me just go through I have one here for the ultra sensor. What I'm doing is I'm using a very similar command, which is the range find distance. But let me just run this just so that we can see the distance to run. Okay. So we always have a plan B when it comes to live demos. Okay, so this is running right now. We're going to press this user button just to start the work. Oh, so it still has a distance. Okay, distance of 0. Okay, so this is where that typically what happens is that the distance would actually go from an actual number. If you put an object closer, the number will be a smaller number. If the object's further away, it will be a larger number. Okay, so what I'm going to do is I'm just going to do a quick test if I can. And let me just see if I can maybe stop this. And what I can do is I can try the script again. Okay, so what I'm going to do is I'm going to, so let me just double check, repeat, do while true, print the sonar distance, and then it's going to wait every half of a second. Let me actually just put this, it was working for half a second before, but let me just try 1 second. And let me just, let me run this. Okay. Okay, so it's still the value of 0. So let me just stop this. What I'm going to do is I'm going to restart the robot. So I'm going to turn it off. I'm going to unplug the micro USB cable. I'm going to plug in the micro USB cable again, and then I'm going to turn the robot on. Okay. I'm going to close this one. And then I'm going to go back to Bella's block code. I'm going to try to run this and see if maybe by restarting the robot, the distance finder will, there we go. Okay, so so when there's nothing in front of it, it'll be running at about 65,000 centimeters, which is quite large. But when she puts her hand in front of it, the closer her hand, it's a smaller number, and as the hand goes further away, the number gets larger. Perfect. So as a tip, if the ultra sonar sensor, range sensor provides a value of 0, just restart the robot as a tip. Perfect. Okay, awesome. So I'm just going to stop that. Excellent. And what I'm going to do is I'm going to do the same thing for the MicroPython. I'm just going to copy the imports, the libraries and modules. Then I'm going to copy the actual Python coding, and I'll put it down below. And then I'm going to run this. I'm going to save this as in the root folder. And then I'm going to put it to letter E as in Edward. Okay. It's going to save. Okay, so there's the values there. When nothing's in front of the robot, it's a large, very large number. When she puts her hand in front of it, closer, it's a smaller number. Further away, it's a larger number. Awesome. Any questions in regards to the ultrasonic range sensor? Perfect. Okay, so what we're going to do is move to the last function here, and this is where we talk about the IMU. So the XRP circuit board contains a very useful sensor called the inertial measurement unit, called the IMU. The sensor uses several internal sensors to determine what direction the robot is pointing in, as well as the acceleration of its primary directions. So in this example, we are going to be using the yaw, which is basically what position or degree is the robot facing. So the quick tip is that whenever you use the IMU, whatever direction the XRP robot is initially facing, it will be 0 degrees. If the number is positive, it will turn the XRP robot to the left. If it's a negative number, it will turn the XRP robot to the right. So if you look at this little graph chart here, anything to the plus, it will turn from 90 to 180 to 270 back to 360. If it's a negative number, it will turn to the right, which is minus 90, minus 180, minus 270, and then back minus 360, which is 0. Okay, so for this one here, what I'm going to do is I'm going to use this code, and I'm going to put that into the MicroPython. Okay, I'm going to close the this file here, go to MicroPython. I'm going to copy and paste this Python code here. Basically, what I'll do is I'll just explain it really high level. So first, we're going to import all the XRP libraries and functions. We are going to define a function called turn with an argument called target angle. We are then going to call this turn function below by putting in parameters. 45 will turn the robot to the left, and then minus 45 will turn the robot to the right. And so in the function, basically what we do is we get the current angle. So when the robot is first running, whatever direction the robot's in, it'll think that it's at 0 degrees. So we're going to use the round function to get a whole number. We're going to use the imu.get_yaw function to get the actual degrees. We're going to print out the current angle is this angle, and then the target angle is going to be this angle. So for our example, it will always start at 0 is the current angle. And if we use the first call of the turn function at 45, the target angle will be 45. We use an if statement. So if you want to turn the robot to the right as a negative angle, this is the code for this condition. If it's a positive number, we will be using this condition. So by using the example, we use a variable called degree, and it basically takes the target angle argument and assign it to that value, which is basically 45. It'll print the target angle is 45, which is target angle is 45, while the current angle is not equal to the desired degree. So if it's facing at 0 and the target angle is 45, it'll run this loop. We use the drivetrain library and the turn function, where we slightly move the robot slightly to the left, slightly, until it reaches 45. And then it basically stops. So what we basically have done is we have a starting angle, which is 0. We have the target angle, which you put into the call function. And then while the current angle is not equals to the degree, it'll either turn to the left until it's 45, or it turns slightly to the right until it hits 45. Okay. Any questions in regards to this function here? Okay. So what I'm going to do is, what we've done is that, and so what we basically done is that for the project that the students that was participating in our program, we created a final project for them. And so Bella's going to walk you through the project. And by using those 6 commands, the robot will autonomously help St. Nick. Okay, over to you, Bella.
St. Nick needs your help. He is running behind schedule. Program the robot to perform the following activities. First, place the robot anywhere on the city map and it will return to the starting position. The robot will pick up a special gift, A, B, or C. The robot is traveling, must stay on the road. The robot delivers the special gift at X, Y, or Z. The robot performs a happy dance. Lastly, the robot returns to the waiting position.
Okay, so we have a video here of the robot actually working completely autonomously. And so what I'm going to do is we'll speed up the video so that you can see this live in action. Now, as you were seeing before on the slide, is that we have ceramic tiles. And so there are grooves in between the tiles, and sometimes the tiles did not grip consistently. So you're going to see the robot turn to the front here because we have wooden boards at the front, and it's going to use the left-hand wall to determine where its position is. So it'll look to the front for the position, it'll look to the left wall for position, and it will automatically adjust. Okay, so let's go to the video, and I'm going to run it at a little bit faster speed. So let me just go back here. I'm going to press play. Okay, so we have a special mission. The key requirements, as we stated before. So here's our map and our ceramic tiles. We have wood in the front, and it's using the wood in the front and the wall to put this in. So it basically goes back to the starting position. Then it moves down this road and it picks up the special package. And here it's going to pick up package B. Okay. We have little green markers on the floor, so that's where it's supposed to align. It's going to look to forwards to readjust. It looks to the wall to readjust. It travels down the highway. It looks to the wall and the boards in the front to readjust. It goes towards the, okay, it's looking to the front to readjust. It looks to the wall to readjust. Perfect. It goes down the road and sees the 3 houses. It determines that it wants to drop it off in house number Z. It does a happy dance by spinning around and raising and lowering the servo, and then it returns back to the waiting position. Awesome. Mission successful. Any questions in regards to this project?
Yes. So sorry. So again, so is this did you make some of these, or is this some of your creation, or are all these posted on that public website, wpi.edu?
So great question. So there's a lot of postings in regards to projects. What we did was we combined a number of different projects that were located on the website, and we basically created that for the final project for our students. So again, there's a lot of material that's out on the website. What we're trying to do is that because we taught them a list of 6 different functions, we were trying to provide a project that would leverage those functions, and it was up to them to determine how to do that. So it was using functions to autocorrect its position, as well as autocorrect its angle as well. Any other questions? And you can always reach out to me if you like, because we actually have a scoring point for every time that it completed major activities. They scored so much points, and it was out of 100. And so all of our students was scoring above 80%, which was brilliant. But it did take about 3 or 4 weeks for them to design it and to test the robot in our city map. Any other questions? So I'm just looking at time. So we have about 5 minutes here. And so what I'll do then is go back to our slide deck. So I'm just going to just go through this part really quickly. So Marsh has already showed you the robot simulator using the WPI robotics library. So when it comes to setting the robot up to be able to use this WPI robotics library, it's basically 2 steps. One is to update the firmware, and number 2 is to install the WPI robotics library environment and create a new project. And then basically connect the robot, your computer, to the robot's network, to its access point. And then you're going to be able to remote control the robot using the simulator. And so what we provided here is the actual instructions on how to factory reset the, oh, sorry, that's the other one. Let me close this tab here. Okay, so this one here is how to operate the XRP robot using the WPI robotics library. So this shows you step-by-steps on how to update the firmware of the robot. It then explains to you how to install the WPI robotics library environment. It will then also explain to you how to create the actual project, which is we chose the example Java XRP reference. And then once you have that project created, it shows you how to build the project, and then how to connect. The robot simulator screen will appear. You will then, once your joystick's connected to your computer, you will just drag it into the joysticks window. Please uncheck mark the map gamepad, and then you basically simply use a joystick to remote control the robot, just like Mosh has done. Okay, and so we actually provide you the step-by-step instructions on how to do that, and that's all provided in the instructions itself. Okay. And of course, if you do have any questions, you can please feel free to reach out to us. A lot of these examples was actually from other FRC mentors, Spark Fund engineers, as well as from individuals on WPI as well. So basically, just quickly moving to the lessons learned. So there's 5 key lessons learned. So at the beginning, some of our students, computers could not detect the XRP robot. And it was seen as an unknown device. What we did was we bought the official Raspberry Pi cable, and this resolved the issue. So a quick $5 solution resolved that issue very quickly. In terms of the batteries, the sensors will use a lot of power. So after 2 hours using regular AA batteries, the sensors like the ultrasonic range sensors will stop functioning properly. So what we did was we moved to lithium batteries, and we provided a link where you can buy those from Amazon. And our classes are between 3.5 to 4 hours, and those batteries lasted until the end of the class. Another thing we learned is that there was separate firmware for the XRP code editor, and there's separate firmware for the WPI robotics library. So if you have those 2 available, which is in the presentation, you can get the latest and greatest of both of those firmware. In terms of learning curves, we do recommend you to stay curious during your journey. There is a little bit of a learning curve, but to be honest, the community helped our team in regards to being able to build and to program and operate the robot. So I do advise you to get involved, sign up on the XRP discourse group. And I'm going to just show you that really quickly here. And they have a number of different areas within the discourse group. They have hardware, coding, curriculums first, as well as support. If you want to post any questions or just read the existing posts that are being showed. Okay. Any questions when it comes to the key lessons learned? Okay. This is what I'm going to do. I know we have a minute, so I'm just going to go round table in terms of asking for any questions. So John, do you have any other further questions for us? I know there's a lot of material.
No, it's been presented really well. I think once the students get their hands on it, they may decide to give me some questions. Yeah, we'll probably just be staying with coding it pretty straightforward and WPI lib and stay that way. A lot of students have asked about going to Python. We coded last year in Java, and that's where my leaning is towards. And some of the other mentors are more into Java than they are to Python, but I think we'll stay with that. So yeah, it's going to be a learning area, but it's one of the programming tasks I have on my list of objectives, just for them to, especially the new ones, the rookies. I have a couple of returning programmers, but I have a couple of rookies. I think I'll just give them this thing and let them play with it and see how it goes with that. So, but no, your material is real well presented on I think I'll try to make a list of all the resources and hand that out either tomorrow night or our second meeting. So thank you.
Oh, perfect. Thank you very much. Louis, do you have any other questions? Louis, do you have a...
Okay, well, I'll jump into the question then, if that's okay.
Oh. Excellent.
Sorry, hello, can you hear me?
Yes, we can.
So same question for you. I'm not too sure if you're familiar with Swerve, but my long-term goal is to, or maybe shorter than long-term goal, is that we can't afford Swerve, and my team is always thinking about Swerve. So I had this idea of like using the XRP, since it's WPI code, to play around with Swerve. Like, do you have any thoughts on that?
So interesting enough, we were there was a SWAT posium. I think it was within a month ago, and this is where actually I met William in person. And there was a team who was actually presenting about Swerve. You're right; it is a little bit more expensive of wheels to operate, but we went to the McMaster competition this year, and you saw robots outmaneuver other robots that were using, say, for example, the tank drive. So again, I think a lot of teams are thinking about using the Swerve wheels. I think it's a little bit more versatile when it comes to driving or operating the robot. But again, there's a lot of teams who have already built it as well as programmed it. And it's really the FRC community just reach out to teams who have already done it, and then ask if they're willing to share some code and some best practices, if that makes sense.
Oh, cool. Thanks.
Absolutely. Mosk, do you have any other questions? Excellent. So what I'm going to do is we're going to jump to, again, encourage to get involved in terms of any of the community groups. It's a great way to share and collaborate because we're all trying to achieve basically the same type of goals. We're maybe perhaps in different portions of our journey, but we've learned a lot from other teams. So we're very grateful for the knowledge they provided. And so when it comes to this, so we hope that you learned at least one new thing from this mentor session. As always, if you have any questions, please feel free to reach out to me via email or give me a call.
Again, a special thank you to William for providing us with this wonderful opportunity to give back to the FRC community. Thank you.
Thank you so much.
Well, most appreciated to Moksha and to Stephen and to Bella. What a wonderful set of presentations this evening. And that will certainly be useful throughout our entire community for getting FRC teams and others interested in the robotics. So
Sorry, one question before you go. So, Stephen, would you be interested in sharing your slides in that case?
I think I'll be able to share them on the YouTube link once they're up, and you can check in a few days on the YouTube channel. It should be up there.
Okay, sure, thanks.
Well, thank you very much again. I hope everyone has a wonderful evening, and we will hope to see everyone very soon at some kind of event. And